video, we'll discuss the important concept of conditional probability. So often in the world, we update our probability of something being true based on what we observe. So if your favorite soccer team wins 8 games in a row and they had previously lost a bunch of games, you might probably think they have a better chance to win the league championship. And that's what conditional probability and later Bayes' theorem that we'll discuss is about. So we talk about the probability of an event A given that we know B has happened. And it's the probability that both have happened divided by the probability of the given event. Okay, now you can rearrange this to say the probability of A and B, if you multiply both sides by probability of B, it's the probability of B times the probability of A given B. And you could actually flip this and say the probability of A and B is the probability of A times the probability of B given A. So you want the probability of two events occurring, called the joint probability. Take the probability of any one happening and multiply it by the probability the other event will happen given you know the first event happened. And we can tie conditional probability to independence. Events A and B are independent if and only if the probability of A given B is the probability of A, which means if I told you B happened, you don't change your estimate of the probability of A. And the probability of B given A is the probability of B, which means if I told you A happened, you don't change your estimate of the probability of B. So let's look at some examples. So we have two sample spaces here. What's the probability of A given B here? Well, we need the probability of A and B. The A's mean it's event A, the B's mean it's event B, and A and B means it's both. So we have 20 points in the sample space there, assuming they're equally probable. The probability of A and B, there's just 1 point there, that's A and B right there. So that's 1/20th. And then you have to divide by, if we look at the definition, the probability of B, so you count how many points are B. And that's 1, 2, 3, 4. And so the answer would be the probability of A and B, 1/20th, divided by 4/20ths. And that would be 1/4. Okay, and that makes sense because if I tell you B happened, basically you're in one of these points here. You'd be in one of these 4 points, right? So if I told you B happened, you know it's like what we call reduced sample space. One of those 4 points. Now what's the chance of A? Well, it's 1 in 4. Okay, now A and B are not independent because we look at the probability of A and B, or actually just use our definition here. Okay, A and B are not independent because basically the probability of A given B, okay, is 1/4, and the probability of A by itself is 8/20ths or 2/5, because they're 8 points. So these are not the same. In other words, when I told you that B occurred, it lessens the chance of A because we took away all these points on the left. Now let's look at a second example. So we have 20 points here. We have the A's and B's scattered about there. So what's the probability of A given B? We need the probability of A and B first. Now, how many points have A and B? Well, there's 2 of them. And then I have to divide that by the probability of B. How many points have B there? Well, it looks like there's 5 of them. Okay, so the probability of A given B is 2/20ths divided by 5/20ths, and that's going to be 2/5. Okay. Now, then A and B are independent here. Why? Okay, because before I told you anything about B, how many points would be A here? Well, there would be 8 points that would be A, right there. Okay, and so the probability of A would be 8/20ths or 2/5 before I knew anything else. And once I know B occurred, it's still 2/5 because there are 5 points for B. If I put this in a different color. And 2 of those basically involve A, so the chance of A is still 2/5. Let's look at some more concrete examples. We deal with dice or a deck of cards. Let event A be the event we get at least 1 6 with 2 dice, and B is the event the total is 10. What's the probability of B given A. Okay, so in our first, let's put this in a different color so we can show it's different. Okay, so if I want to solve the problem in yellow here, basically I need the probability of A and B. That'll be the numerator, and I'll need the probability of A. It doesn't matter what order I do this. Well, how can I get A and B? So I need at least 1/6 and the total is 10. Well, how can that happen? That can happen if I get a 6 and a 4, or a 4 and a 6. Okay, so that's basically how I can get at least 1/6. Okay, sorry, get a total of 10. Get A and B, which is the total is 10. I get at least 1/6, and so that would be 2 chances out of 36. So that's the numerator. Now, what about the denominator? That's probably at least 1/6. Now, to get at least 1/6, basically, let's just put x's there. 1, 2, 3, 4, 5, 6, but 7, 8, 9, 10, 11. You can't double count the 6, 6. You can't do 6 plus 6. You have to do 6 plus 6 minus 1, like we've talked about. So the probability of A would be 11 over 36. Okay, so now the probability of B given A, probability of A and B, which is 236. Excel loves to put those dates in there. And then I would divide by 11 over 36. And the answer would be 2/11. Okay, now let's look at our second example here. Put that in 2/11, sorry. February 11th to Excel is 2/11. Okay. So now if I look at the second problem, A is the event the first card is an ace, B is the event the second card is an ace. I want the probability of B given A. So I need the probability of A and B there. Okay. Actually, I don't need to do anything here. Okay, because basically, probably a B given A, if we just think about this, what's probably the second card is an ace given the first card is an ace, and we're assuming this is without replacement. So when you take the first card out, you don't put it back in. Well, I could do this more formally, but I don't need to. If I tell you the first card is an ace, okay, what's probably the second card is an ace? Well, now there are 51 cards in the deck and 3 are aces. So the answer is going to be 3 over 51. And that's going to be 1/17. Okay, and that would be the answer there. And here A and B are clearly not independent, because I tell you basically that the first card is an ace, it's going to change the chance the second card is an ace. Because the chance the second card is an ace, probably at B, if I tell you nothing, is the same as the chance any card in the deck is an ace, which is 4 over 52. And that is not the same as 3 over 51. So A and B are not independent here. And the example we did with the dice, I probably should have talked about the independence there. Okay, we don't have independence here either, because basically what was the probability of B here before we knew anything? The probability of getting a 10, there are 3 ways to get a 10. 6, 4, 4, 6, and 5, 5. That would be 3 over 36. And see, that's not the same as once I know A, it's 2 over 11, which is much bigger than basically 3 over 36. The idea being, if I tell you there's at least 1/6, you know you have a good shot at getting a 10. Okay, before you know anything else, you don't have that much shot at getting a 10, because if you get a 1, 2, or 3, you can't possibly get a 10. So we're going to follow up and use this idea of conditional probability in the next 2 videos with the law of total probability and the culmination of our study of probability, which will be Bayes' theorem.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here. and you can sort of see 4.5, or his newest book, his Analytic Stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.